Hi guys, good morning. Well, good morning for the California time zone here at 9 a.m. For all of you who are joining in the evening, good night. If it's kind of in 2 a.m., 3 a.m., I don't know if that's morning or night, but thanks for joining. Today is our very first Web3 Unleashed call. So if you guys don't remember or if you didn't join our community call, on Friday, basically, brief overview is Truffle will be dropping kind of Web3 learnings surrounding development, whether that be building a dApp together, talking with industry experts, or exploring just like various smart contract conventions, diving into how we make things more secure, is what this kind of series is about. So to get started today, let me share my screen so I can bring up some slides. Cool. So just to get started, essentially, Web3 Unleashed. Today, we're going to talk about writing an NFT smart contract with royalties. So specifically diving into what ERCs, EIPs are, why they matter, talking specifically about the ERC 2981. So that's going to be the NFT royalty standard, what that looks like, what that means, and actually implementing it together. First, going to touch on some just basic 721 basics because we will be doing an NFT. So that's the ERC 721 coupled with the royalty standard. So that's 2981. Then project setup, and of course, my favorite part, coding together. So writing the contract together, testing it, and then talk about some ways you guys could extend it, incorporate it into your own dApp, start building in Web3. And at the very end is when we'll go over questions. So yeah, let's get started. So just touching over, like first off, let's talk about EIP. So EIP stands for Ethereum Improvement Proposal. So what this is a technical design document focused on one, proposing new features, two, collecting community technical input on an issue, three, documenting the design decisions that have gone into Ethereum. This comes in a variety of flavors. So the most common type of EIP is the standards track. So that's basically anything that will affect the implementation of Ethereum. That also comes in a few subgroups. So there's the core standard EIP. So that's going to actually be what you could say a core change to Ethereum, requiring either a consensus fork, which is going to be something like a major change to the rules of Ethereum. So one example of an EIP that did this was changing how the way gas is charged when you're making transactions. Other than that as well, core things might be just EIPs focused on something very crucial to development in general. The next piece is networking standards. So this is actually pretty uncommon. This is focused on like the peer-to-peer protocols surrounding Ethereum. I'm not going to dive into them, but just to throw out the words there, Dev P2B, Light Ethereum sub protocol, and the protocols Whisper and Storm, which I think are relatively old, hence networking not being the primary form of standards EIP. Third piece here is the interface EIP. So that's just going to be pretty self-explanatory, standards around the interfaces when interacting with Ethereum. So that's your API specifications, your RPC specifications, focusing on language level standards such as method names and contract APIs for your smart contracts. And the last type of standard, ERC, my favorite one and the most common one, is going to be changes to application level standards. I'll dive more in depth into that later. Let's continue talking about the different types of EIP. So this other piece there's two more. So there's meta EIPs, basically changing the processes around processes. So pretty meta. And the last one is informational EIPs. So this is just kind of general information describing Ethereum design issues, does not propose a new feature. So because these EIPs are not necessarily a community consensus, users are free to ignore them, but they are very helpful, so I recommend reading through them. Yeah, so that's EIP. As I said before, we're going to dive a little deeper into ERCs, so Ethereum request for comment, application level standards. So that's stuff like token standards, name registries, URI schemes, library formats, and wallet formats. Next piece is, what exactly does that look like? So an ERC essentially defines required functions that your smart contract needs to implement. What that does is kind of establish a shared language so that other apps and contracts can understand what exactly is in your ERC, right? So keep in note that this is not considered part of the core standards EIP, meaning adoption is optional. So for example, ERC 721, not every single contract has to be an ERC 721. As ERCs coming out, it's kind of on the community to say, hey, we want to adopt this, make this successful, which is actually why I decided to do one on the royalty standard. Because I think adoption for the royalty standard needs to increase. It's a really great way of standardizing how we are paying royalties to the artists and musicians creating NFTs, driving the Ethereum ecosystem. So yeah, today ERC 2981. But, I am waxing poetically. Why did this matter? First off, EIP is really cool because it's a single unit of governance in the Ethereum community. So that's how we as a collective make decisions about Ethereum. Anybody can submit it, including all of you guys here on the call today or those of you watching later. The guidelines are on the Ethereum website in EIP. And the next part about ERCs, like I said, it powers composability. So if you've been in the space at all, you hear these buzzwords like composability, interoperability, just working together. As I mentioned, shared language. So basically, my dApp can interact with your contract and unlock all these new use cases as we kind of bring down walled gardens in a sense, because we can understand, hey, you have these functions, you have these properties, your contract looks like this because it fulfills this ERC standard. So let's dive into the 2981. So as I mentioned before, ERC 2981 is the royalty payment or NFT royalty standard. Again, like I said, because it is not core, this is not enforced. Additionally, on the ERC 2981, the way it is structured does not enforce the actual payment to happen. Rather, it signals that there is royalty information on there in a standardized way. So if you are creating an NFT that has these properties, do note that it is on the marketplace to decide whether or not to take that information to account. So marketplaces such as Coinbase NFT, Rarible, Super Rare, Zora currently do respect royalties signaled in an ERC 2981. OpenSea does not. You will have to configure that separately yourself on the website. So obviously for you builders there focusing on building marketplaces, there's definitely an incentive to take into account accepting ERC 2981's checking for that royalty information. Second piece, I keep saying NFT royalty standard, that's the biggest use case, but it does not require that it's compatible with ERC 721 or ERC 1155. So these are super popular standards that exist today. Specifically the NFT standard, 1155 is a multi-token standard. So that's basically a contract that includes both fungible and non-fungible tokens. So you can kind of reword this as the universal royalty standard. So again, ERC is super flexible. This one in particular, any contract you write can signal royalty informations through complying with this 2981. I'm actually going to dive into what an EIP looks like specifically for this ERC. So as you can see, Ethereum Improvement Proposal. So EIP was the proposal made. ERC is the final comment that was finalized to be accepted by the community. Simple summary, abstract, motivations. In the ERC specifically, it gives you a view of what that would look like. So stepping through what an ERC 2981 should look like is, number one, it should fulfill this interface extension. So ERC 165 is essentially the interface standard. It is what allows other contracts to basically check whether or not your contract fulfills a specific standard. And as I said before, super lightweight does not enforce the actual payment to happen. It just signals that it exists. So taking in a token ID, so that's going to be the unique identifier for an NFT, the sale price, so how much it's going for, and then we'll return receiver. So receiver is who's going to be receiving that royalty payment, as well as sale price, royalty amount. So the amount that needs to be paid to the receiver. And then also in this EIP gives an example of what it might actually look like for your marketplace to check whether or not it's an ERC 2981. Again, very straightforward. Basically, it returns a Boolean checking for this specific ID, which is defined here. So yeah, stepping through again this EIP, it talks more about, why this is important. And kind of considerations and obviously copyright citations. So dive into it if you want some more in-depth reading or write your own in the future. But now I'm going to move on to coding. So we're actually going to build one together, probably why you joined this call, the most exciting part, how to do it yourself. So project requirements for the dApp we're going to write today, obviously Truffle for deployment, testing, the Ganache CLI or UI for the local testing as well. If you want to deploy it into testnet, for example, to see it on OpenSea or in your mobile wallet, you will need an Infura account alongside MetaMask. I will be using the VS Code IDE alongside the, Truffle VS Code extension. And at the very end, we always need that money to pay our gas fees. So we will need some test ETH, which you can get from a faucet. My favorite faucet is going to be the Paradigm faucet, which I will have links to later. So let's actually get started. I'm going to check really quick if anything has gone wrong. Cool. Everything is good and peachy. So the first thing that we are going to do is actually start a clean Truffle project. So what that looks like is just a simple Truffle init Truffle init, and I'm going to call the folder NFT royalty. So essentially, Truffle init just scaffolds a very basic Truffle project for you. I do want to note that we are cleaning this up to make it even more robust for you guys. So if you're watching this in the future, this specific video will probably get out of date really fast, but that's fine. The basics are there. We will have an up-to-date blog post for you to follow along with just kind of the nitpicks of how Truffle init is going to be different. Anyways, so we've scaffolded our project. We have these nifty functions to basically quickly create your contracts. So I'm just going to call this Truffle create contract. Let's call our collection Royal Pets. Oh, whoops. We need to actually get into the folder itself. And then I can call Truffle create Royal Pets. And then let's create another one called test Royal Pets to make sure our NFT with the royalty standard will work. So now that that's done, let's actually open it up in VS Code. I'm going to pull this here. Nice. So brief overview of what is in here. Like I mentioned, we created the Royal Pets contract as well as this test here. We actually don't need this migrations contract. That's an old construct in Truffle, which will be removed in our next Truffle init release, but we can go ahead and delete that. Let's rename this guy to just a deploy contracts because we no longer need that, migrations file. And yeah, And we can delete this one too. So that is our clean project. Let's actually now dive into building it on our own. So the first thing I want to say is OpenZeppelin is really awesome. So OpenZeppelin essentially provides pre-written security, well-tested contracts already to kind of just inherit into your smart contracts. We are very lucky. OpenZeppelin has already written example contracts for the NFT royalty standard. And so in order to use that, we just need to do an npm install add OpenZeppelin/contracts. And we will have that available. Now, all you need to do, if we are doing specifically a 721 with the royalty standard, is import it. So that's going to be the ERC 721 royalty. And I can just go ahead and say that it is a 721 that has the royalty standard. This guy now needs to implement the actual, what do you call it, constructor. So let's call this ERC 721. And it'll take in royal pets as the name of the collection. And then I guess the abbreviation we just call RP. So that's basically almost all you need to do. Of course, we need the minting function and other additional things. But just to dive into what OpenZeppelin has provided for us is essentially, you can see here, it's saying it is the ERC 2981 as well as the 721. In particular, it says for this royalty standard, OpenZeppelin has provided a simple burn override. So burning your NFTs, which essentially means changing, like burning your NFTs away from your wallet, returning it to the 0 address. Sorry, just circle back. What the royalty standard does here with OpenZeppelin is essentially reset token royalty, which in the ERC 2981 contract that is also written by OpenZeppelin deletes token royalty info. Let's dive into what that actually means. So OpenZeppelin has already implemented what the default, what royalty info looks like in their example ERC 2981. Very straightforward. Essentially, the way the royalty amount is, calculated is the sale price times royalty fraction. So this is going to be a number that we populate divided by fee denominator. If you look at the, docs here, this essentially calculates what percentage of the sale amount you want to give in terms of basis points. So if you're not familiar with the concept of basis points, that basically represents 1/100th of a percentile. So in this case, when we are setting up our royalties, if we say that the royalty fraction is 100, so 100 basis points, that's equivalent to 1% of the sale price. If you look a little further, they have this concept of token royalty and default royalty. So what that means is with the OpenZeppelin contract, you can set default royalties, which is going to be a contract-wide royalty. So you're going to say, if there's no token royalty specified, I want the royalty to always be paid to this person with this royalty percentage. For token royalty, you can kind of think of this as a concept of what if in your collection you have multiple artists contributing to it, and this specific token that I mint should be have the royalty paid to a different address than the default. So that's what token royalty allows you to do, is override the default royalty info if you want to kind of change the parameters. Again, this is the OpenZeppelin implementation of it. All of this is actually could be empty on your part. So if you want to customize this as you wish, you're completely at, will. You are allowed to do that. Cool. So let's dive back into our actual contract. If we want to actually set that royalty, we can say, hey, when we are going to deploy our contract for the first time, let's set a default royalty to the receiver. And I'm going to say the receiver is going to be the owner of this smart contract. So message.sender is going to represent who deployed it. Fee numerator, let's just say 1% of the sales. So that's going to be 1%, 100 basis points. And that's all you need to do. But I'm actually going to make this a little bit more complicated. So when we're talking about ERC 721s, like NFTs, there's this idea of token URIs. So if you guys aren't familiar with, how NFTs are constructed, essentially the thing that makes your NFT beautiful, so the rarity, the images, the music that goes with it, is called metadata. And typically that metadata is going to be stored off chain. Usually in decentralized storage, like IPFS, for example. And that's essentially the token URI is a pointer to that information. When we are minting our NFTs, OpenZeppelin actually also provides another extension of ERC 721 called URI storage. Let me pull this up. I think it's this one. Cool. Essentially what this does is it's going to store that token URI on chain when you mint the NFT. What this allows you to do is decouple the token ID, so that unique identifier, from the token URI, which is really helpful if you want to do kind of a incremental increase of the token ID with each mint. I will actually write that down in code so that makes sense. But we have these two. So let's say is ERC 721 URI storage. As you note, our compiler is actually complaining, and that was intentional to show you guys what that looks like. So specifically, they are both overriding burn and supports interface. Obviously, we don't want that. So maybe one way we can resolve it is, if you saw in here, it extends ERC 2981, which is kind of the base case. So instead of ERC 721 royalty, let's go ahead and also import 2981, remove this guy, and then remove this guy. 2981. Does that fix our problem? No, because both of these guys do override supports interface. So if you guys remember, supports interface is essentially what tells another contract whether or not it's going to support that ERC 721 interface and the ERC 2981 interface. Obviously, these guys overlap, because URI storage is going to, I don't remember where it is. Here we go. Override it to signal 721 information. 2981 is going to override it because it's signaling the 2981 information. So in order to fix this, we're going to need to actually override it ourselves. Very simple. Essentially, just call it supports interface. It's going to take an ERC, override the ERC 721 and the 2981. In terms of these specific kind of attributes on the method name, virtual means that contracts that are going to inherit royal pets, for example, have the ability to override this function. Override is just saying it's overriding a function. So pretty straightforward. Here's supports interface. Let's move on. So if you remember, when I was talking about the royalty extension, they added on to burn, in the sense that it also took into account burning the token royalty, or resetting the token royalty. However, because we are no longer using that extension, we don't have that functionality anymore. So actually, to maintain that, I also want to override the burn functionality. So again, just going to paste this in here so I don't type it incorrectly. We're overriding burn, super.burn as you can see, is going to use both the 721, which is going to clear out like the address information. The burn function in URI storage is going to clear out the token URI. But yeah, and then we added on that functionality that we lost when we were no longer extending royalty, the ERC 721 royalty open Zeppelin contract. Okay, cool. So now that we kind of have these pieces of what we want that ERC 2981 to look like in Royal Pets, let's actually get into the minting and burning part. So I want to say here, I'm going to actually include also a public burn NFT function. So essentially, this one's internal, which means it can only be called internally. Burn NFT is if we want other contracts or addresses to be able to call this functionality, we do need to make it public. It's just going to call into burn. And the last piece, like I said, is minting. I'm going to write two different types of mint functions. So the first one is just going to be a standard mint that is just going to create an NFT, and that NFT is going to have the default royalty information. Then I'm going to create a separate function called mint NFT with royalty. And this is going to be called specifically when we want to mint an NFT that has that royalty per token royalty information on it. So first off, in order to do this, I'm going to say import counters. So this is an Open Zeppelin counters file. This essentially defines a counter that says increment goes up by 1, decrement goes down by 1. And then also create a, variable for token IDs. So as I had mentioned before, each NFT associated with a unique token ID. We're going to achieve this by every time we mint. We're going to increase the counter by 1, grab that token ID. It will be unique because it's monotonically increasing. So again, just copy pasting external code because I don't want to type this in front and mess up. Here, the NFT function. So it takes in the recipient who's going to receive the token, as well as the token URI. So that's where the metadata points to. Really straightforward, increment token IDs, mint it, set it, and then return the new ID. Again, these are functionalities provided by the Open Zeppelin contract because we inherited ERC 721. The last piece here, as you saw, I put, there's a squiggly line under only owner. It's because we haven't imported ownable. So let's just define this. So what only owner does is essentially say that the only person who can mint a NFT from this collection is going to be the owner of the contract. If this is not something you want, that's something you can remove. But it is an optional parameter you can add. And then, like I said, we're going to create one with a per token basis. So in this case, same idea, recipient, token URI. The difference here is we want to specify a different address that will be accepting this royalty, as well as perhaps like a different royalty amount. So maybe artist number 2 actually wants 20% of the royalties or something like that. That's where you would put your basis points in here. And again, you mint NFT. The only difference is going to be setting that token royalty. So this function was inherited from the ERC 2981 contract here, which specifies for this token ID, I want the royalty info to signal that we are paying to this address for this amount. So that is everything in our contract. How do we know it works? Well, we have to test it. So in order to test it, we will need to deploy our contract. So in here, we're going to change this to Royal Pets, Royal Pets, Royal Pets. Very straightforward. We're only deploying one contract. So that's all we need to do. The second piece, is actually starting that local instance. So there are a variety of ways to go about this. You can start directly from here, just a Truffle develop, which will open up essentially a Ganache instance for you and allow you to directly interact with it in the terminal here. I'm going to clear this. The other option, like I said, we have this VS Code extension. You can create a new Ganache instance here, or you can start it through the CLI, or my favorite one for demo purposes, as well as just development purposes in general, is the Ganache UI. So a variety of ways you want to interact. I prefer the UI. I also think it's super beginner friendly for those who aren't very familiar. So let's start a new workspace. I can call it Royalty. I'm going to go ahead and add this project. What did I call it? NFT Royalty. Truffle config. So this is also an optional part. But what this allows us to do is connect your Ganache instance to your Truffle project so that it knows kind of what additional things it can interact with. So see your contracts. Nothing has compiled yet, so this is going to be empty. But yeah, if you want to deploy this locally, super easy. We just do a Truffle migrate. I do want to note before you do this, make sure that in your Truffle config, let me pull this down, that development environment matches. So when I spun it up with Ganache UI, it's 7545. So actually I need to change this to 7545. And now if I just run a Truffle migrate, that should deploy it. Yep, cool. And as you can see, now we have all of our contracts here. This is the guy we deployed. These don't need to be deployed because they were just inherited. That transaction was recorded here. As you can see, blocks and accounts. It took money from the first address. So yeah, that's how you would deploy a contract. But again, we actually want to test that it works. So this is where we're going to be going into test royal pets. So this needs to change actually because this is not test royal pets. Our contract is test royal pets. We will be interacting with the various accounts. So we want to uncomment that. And then royal pets. So for testing, you have also a lot of choice. You can write your tests in JavaScript. This is Mocha Chai. You can write it in TypeScript. You can also write your tests in Solidity. For the purposes here, we're just going to write it in JavaScript. So the first thing, when we're testing is, what code did we change? Well, we overwrote the supports interface functionality, right? So we do want to test that it properly identifies that this contract is an ERC 721 and an ERC 2198. What that does is basically we can get a contract abstraction that Truffle provides through just a simple contract.deployed. I've already identified what the interface IDs are for 721 and 2981. So essentially, all you need to do is do, does Royal Pets support the interface ERC 721? Does it support 2981? Check that it is equal. Hopefully this will return true. That's the goal. The second thing we also want to test is actually that royalty setting. So specifically when I mint with a default royalty amount, when I mint with a per token royalty amount, and then the last piece, what happens to the royalty information when I burn an NFT? So just gonna copy paste that code here as well. Gonna walk through this. So again, grabbing that contract information. When I mint, this is gonna be the default version. I want to just, the first account is going to be the one that receives the NFT. We aren't working with metadata yet. This is just a test, so we can put in a fake string. Second thing we're going to mint NFT with royalty. We actually want to pass it to the second account and with a basis points of 1,000. So in 1,000 basis points represents 10%. Then we can just use the call functionality to say, hey, what is the royalty info for this? Keep in mind, this function right here, royalty info, was defined on the ERC 2981. Just want to show you that again to hammer it home. Royalty info is just here, right? So let's go back to our test. We'll get it basically saying, hey, for recipient 1 versus recipient 2. This is another one, the owner. So specifically, right, for the default royalty info, we said we want to pass it to the owner of the smart contract. Because our smart contract inherited ownable, ownable actually already has a function called owner that will return that information to you. So where is this guy? Right here. So that's where this function is coming from, even though I didn't write it personally. Once we get that information, let's check it's correct, right? So first off, default royalty info should be the owner. Default royalty info should be 10. So this is because, hey, when we call for the owner, for the sale price of 1,000, 1% of 1,000 is 10. For the per token basis, again, the receiver should be this guy that we specified, as well as now, this should be 10%. 1,000 basis points, 10%, 10% of the sale price of 1,000 is 100. So this is what we expect from that information. And the last piece, like I said, is actually burning that NFT. So we are going to be burning that second token that we created. And again, calling that royalty info. It should set it back to default. So we expect basically the receiver to be the owner of the smart contract. And then again, heading back to that 1%. So that's going to be a 10. So to test that, all we need to do is run a Truffle test. This will default use, again, that development network. And it should pass, which is great. And if you notice here, when we go, nothing was paid to the second address. So again, like I had mentioned, royalty info just signals information. It does not actually transfer that royalty amount. That's on the marketplace owner to honor that. So now that it all works, last piece we can do is actually also deploy it to a test net or mainnet if you want. But that's real money. But yeah, so in order to do that, there's, again, a few ways to do it. Specifically, the recommended way is going to be through your Truffle config. So you'll need to create an Infura account. So very simple, Infura, go to your dashboard, create a new key. It's going to be the Web3 API option. But essentially, if you go to manage key, that's going to be your API key that you will paste in. In this config, basically, it's going to need your project ID. It's also going to need your wallet secret key. Let's have that, get it from a .m file. And essentially in this .m file, we will be putting in the mnemonic and the Infura API key. And then when we go to our Truffle config, I actually want to retrieve that information like this, and replace this guy with girly. So I want to note specifically, again, we're updating our Truffle init artifacts, so this should be changed. I chose girly instead of Ropsten because if you also don't know, the merge is happening. Test nets are being deprecated. We are going to be supporting, or the merge is going to be supporting girly and Sepolia. So that's why I chose to use girly here. Again, a caveat, if you do want to see your NFT in OpenSea, you can either deploy it to mainnet, or OpenSea also supports a testnet's OpenSea, though I believe OpenSea only respects Rinkeby. So, I mean, I'm assuming that will hopefully change in the future, but just kind of an FYI. So I'm not actually going to populate this information, obviously, because I don't want to publicize my public key. One way that I really like deploying actually is through Truffle dashboard. So in order to deploy through Truffle dashboard, let me just uncomment this because we're not using it. Is you can just run a Truffle dashboard to open it up, and then a Truffle migrate dashboard, etc. But I'm actually going to deploy through the VS Code interface. So if you deploy through VS Code, actually, first thing you'll need to do, I need to connect to MetaMask. So in this case, I guess I'll be connecting to RinkB so I can show you it in OpenSea. And then I'm going to hit confirm. Nice. Process. Do that deployment. Cool. And that contract should have been deployed. Nice. And the next thing that I want to do is just mint an NFT. I don't want to write a whole new script in order to do that. You can actually interact directly with the network through Truffle console. So let's say Truffle console network dashboard. Say contract equals await royal pets dot deployed. And then, oh, I misspelled contract. But anyways, now we can call that mint NFT. Mint NFT. The address is going to be my address. Let's copy that account number. And then a token URI. So this is going to be something you pin to IPFS. I already have one set up with metadata. And so that is that. I'm hoping this is going to work. Hit enter. Again, this needs to be signed. So let's hit process. Yes, I'm going to pay the gas fee. And we will wait a bit because RinkB is a little slow. And it should be done. Cool. And now if I go to testnets OpenSea, my wallet is already connected. I can go to profile. Right here, you'll see Royal Pets. You've noticed I've done this quite a few times. That's why it's been repeated over and over. Yeah, I don't know what went wrong here. I don't know. It's maybe a RinkB thing. But anyways, so that's kind of it. Super simple, super straightforward. If you are doing this on your own and you are running into issues, I do want to call out the Truffle debugger. It's very cool. So just to give an example, I got confused because when I was writing this, I actually put the incorrect royalty information here, as in the wrong token ID. And I got a little confused. The way I actually debugged this, really cool, is essentially first we need to connect to the development network that we were using. So that was this Ganesh instance. Oh, did my Ganesh instance die? Oh, it did. Whoops. Cool. Yeah, let's try again. Connect to a new network, Ganesh 7545. Enter. Now that it's connected, we can actually do a Command Shift P. Nope, that's not the right one. Command Shift P to pull up the command palette, debug this transaction. As you can see, we have all of this information here. For this particular transaction, you hit run and debug. And I think I was debugging NFT with royalty. So set a breakpoint here, hit play. As you can see now, oh, the token ID was 2, token URI, fake URI, royalty receiver, all of that information is there. And this is really helpful because I had messed up the token ID and I was like, why is this not working? Debugged. I was like, oh, that's right, because I put in the wrong number. Yeah, now I think that's all there is to kind of just creating that ERC 2981. I'm going to hop back into my slideshow. So yeah, what's next? So last piece is different ways that you can play around with this royalty info. As I said, It's super simple. You only have kind of that base method name. So the internals of how you want to do royalty info can be what you want it to be. So some examples that you might want to implement, I would love to see. If you do, tag me on it if you build it yourself. Decaying royalties. So you can imagine changing that royalty info over time. Multi-sig royalties, something really interesting. So the receiver address could be a multi-sig smart contract, which will then distribute that royalty to multiple addresses, for example. Stepped royalties. So if you noticed in the Open Zeppelin version, there actually isn't a, what do you call it? Any kind of built-in error checking, in the sense that if the sale price was like 0 or -1, it would be, what do you call it? It would be, what do you call it? Invalid, right? Because you don't want to pay royalties on a 0 transaction alongside, if you're paying royalties on a 0 contract, 0 sale price, that's just wasting gas, right? Don't want to do that. I want to talk about kind of future live streams. So again, this is our very first episode of Web3 Unleashed. I chose to talk about royalty standard because that's something I'm really passionate about. In general, ERCs are super cool. One that came out recently that I also want to build a dApp around is rentable NFTs. So incorporating that into an NFT rental marketplace. Something Truffle is thinking very deeply about in conjunction with Diligence, our security auditing product at Consensus, is kind of, well, like I said, security, right? So talking about like upgrading contracts. So like, what if your NFT currently doesn't have this capability? Should you upgrade it to include this new information? What are the trade-offs there? Second piece is, how do you actually do it? I don't know if you guys saw, like Vitalik had a post on Viper, which is a smart contract language that I'm really also excited about. I mean, I guess in general, I'm excited about everything. I want to focus on building a Viper dApp. As I mentioned kind of earlier, we did have our first community call last Friday. We will be doing this at the end of the month, once a month, just talking about Truffle specific things, like what we're up to, what we've released, highlighting Truffle community members. And then last piece, like these are things that I've thought of. This is really a platform for builders in Web3 to tell me, like, what do you want to learn? And we'll kind of learn together. So catch us on Discord, post in our GitHub discussions, as well as I think I linked a feedback form. Just let us know if there's anything else you want us to build, see, talk about, invite on. This series is for you guys. So yeah, last piece is, if you want to stay connected, my Twitter is _EMJLIN. Truffle's Twitter is Truffle Sweet. I do want to note that all of this, I know, was a lot of information. I have a written blog post with all the code that you can copy and paste coming out. Should be published sometime today. I will be releasing where you can access that on Twitter, as well as our Discord. So yeah. I did this kind of in a vacuum because I guess I was sharing my screen the entire time. Our last piece now is going to be, how do I unshare my screen? Stop sharing. Cool. Our last piece is now asking questions, I guess. If there's nothing here. So specifically, okay, what is ETH improvement proposal? As I had mentioned before, it's that technical document that basically defines different ways that we can improve Ethereum. What we dived in today was standards, so specifically improving Ethereum by providing a shared language for contracts to understand each other. Let's see, where to download the Consensus software. Great question. So if you want to download the Truffle, like, I guess, information, you can find our, where's the documentation, kind of the installation instructions here. Truffle, Ganache. VS Code is going to be through your VS Code marketplace. Oh, I'm not sharing my screen. Well, what I went to was just basically go to trufflesuite.com, go to documentation. That's where you'll learn how to install. Where else is there? Are there any rewards for attending this meeting? Yes, the reward is knowledge and the ability to continue building in Web3. And yeah, how to create an EIP. As I had mentioned before, I'm actually going to share my screen so you can see. Share screen, share. EIP, I think is EIP-1. Here we go. Ethereum has laid out all of the instructions to create your own. It is going to be in GitHub, so you have a versioned version of it as the community contributes information, ideas, debate, collaborate, etc. on it. Typically, these are very technical documents, so the people who propose this are going to be like core developers, Web3 protocol developers, stuff like that. It's a difficult challenge, but I think a very rewarding one. I'm going to stop sharing again. What other questions are there? Are you sharing the recording code blog post for us to start using right away? Yes, this will come out afterwards. I just need to add some screenshots and it will be out. Why are members sending wallet address? I don't know. Probably because they're expecting a token drop. All I'm doing is dropping information. I'm sorry. Yeah, I guess if that's all the questions, it is time to say goodbye. Again, join our Discord. Like fill out this feedback survey. Oh, there we go. Give feedback. There's this little button. Just gonna ask you some questions about who you are, your Web3 journey, and then also just additional things about how we can improve Truffle, how we can improve these calls, etc. Yeah. Okay, cool. I will also post this link in the chat. Please fill out the type form. Thank you so much, guys. Really glad that all of you are here. I hope that you guys use the royalty standard and empower artists and beyond. Okay, peace. How do I exit out? End broadcast. Okay, bye.